All right, so now we're going to take a look at some word problems. And so one thing I want you to remember or know if you haven't learned this yet is the Pythagorean theorem. And the Pythagorean theorem says that if you have a right triangle, okay, so if you have a triangle that has a right angle, and a right angle is one that is formed by two perpendicular lines, and its measure is 90 degrees. Okay, so anyway, and a right angle, basically we see them all over the place, right? Anytime, most buildings that we have, most walls that we have are right angles, are made with right angles to the ground. Ceilings are made with right angles. Most corners of walls are made with right angles, right, for the most part. And then other things too, like tables and just various items. A lot of things. We're used to right angles, seeing right angles in a lot of forms in the world. So anyway, when you have a right triangle, basically A and B are the legs, or a lot of times we call those the legs, and those are the sides that form the right angle. Those are the sides that are perpendicular to one another. And then C is the hypotenuse, okay? And the hypotenuse is always across from the right angle. So when I'm looking for the hypotenuse, a lot of times I'll just make an arrow with that right angle symbol, and that always points to the hypotenuse, okay? So if you ever forget, you can just make that arrow, and that'll point to your hypotenuse. And the hypotenuse always has to be the longest side, right? Because the right angle ends up being the biggest angle. All right, anyway, all that stuff is stuff that you'll learn with more depth when you get to geometry. But the relationship between the sides of a right triangle are basically, if you square the two legs and add them together, then that equals the square of the hypotenuse. And that always happens no matter what size the right triangle is, no matter how big or small the legs are. If it's a right triangle, this always is true. A squared plus B squared equals C squared, okay? Or in other words, the sum of the legs squared equals the hypotenuse squared, okay? All right, so let's put that into practice. So here we have, it says the length of a rectangle is 1 meter longer than the width, and the diagonal measures 5 meters. What are the length and the width? Okay, so we have a rectangle, and I don't know if you're like me, it always helps to draw a picture. Very visual. So we have a rectangle, and then we have a diagonal, right? Diagonals from one vertex to the other in a rectangle. Okay, so a rectangle has a right angle. So here we see a right triangle. Okay, and it says that the length is 1 meter longer than the width. Okay, so the length is 1 meter longer than the width. So the length, so if this is so we'll call the width x. Okay, so that means the length is going to be x plus 1, right? 1 meter longer than the width. So if this is x plus 1. And then we know the diagonal is 5 meters. Okay, so this would be 5. So it says, what are the length and the width? Okay, well, so what we're going to do is we're going to say, okay, well, we have x plus 1 squared, right? So we'll call this A, and this B, and this C. So we know A squared, that's what I just did, right? Plus B squared. All right, and so that's just going to be regular x squared there, right? Equals C squared. And C is 5, so I'm going to put a 5 in there. Okay, so A squared plus B squared equals C squared. If you want, you can put parentheses around that's not a bad idea. It's especially important when you have negatives or when you have a binomial like this and things. But if you have positives, it's kind of optional. But all right, so now we're going to square. So here we're going to multiply x plus 1 by itself, right, to FOIL it. If you know a shortcut, you can do that. We talked about perfect square trinomials, and so there's a shortcut. You can go straight from there to the trinomial if you kind of remember how you get those numbers. But I'm not going to deal with that right now because we've talked about that before. X squared is x squared. 5 squared is 25. All right, so now we can distribute or FOIL. So x times x is x squared. X times 1 is 1x. I'm just going to put plus x. 1 times x is 1x. 1 times 1 is 1, right? Bring down the x squared. Bring over the 25. Okay, so now we can combine like terms. x and x go together, x squared and x squared go together, and then I'm going to subtract 25 from both sides. Okay, so you don't have to do all those steps at once, but it just saves you a little writing and things. And but if you want to just do one step at a time, you can. So x squared plus x squared is 2x squared. X plus x is 2x. And 1 minus 25 is negative 24. And then we get equals 0. All right, so since it's equals 0, we're ready to factor. So first I'm going to check for a GCF. And it turns out that we have a GCF, right? 2 goes into all of those values. So we can put a 2 on the outside. We divide everything by 2, right? So we're going to get x squared plus 1x minus 12 equals 0. All right, now we can factor. So at this point, this is exactly what we did the other day, right? So the hard part about the word problems is just setting them up as usual, right? That's kind of the challenging part. Once you get them set up and you're into the math, the algebra, then you don't have to worry about the words anymore, of course, and it's just like what we've done before. All right, but anyway, we're looking for numbers we can multiply to get 12 that we can subtract to get 1, right? That invisible 1. So what are those numbers? 4 and 3. Good. All right, and then this tells us the sign of the bigger number. And then since this is negative here, that means the signs are going to be different. So the smaller number will be negative. And then now we can just change the signs, right? There's no coefficient, so it's just going to be simply x equals negative 4 or x equals positive 3. And then remember, this 2 is not going to play into our results here. And so those are answers.